Alright, hey guys, and welcome back to another video. So today we're going to be going over the problem min cost climbing stairs. It's part of week 1 of the June League Coding Challenge. So in this problem, you're given an array of costs, and basically at each index of the array represents like a step on the staircase. And so you have to pay this cost. So if you're at this index, you have to pay 10, and then you can either step 1 square forward or 2 squares forward. And you have to just make it up all these steps in the staircase by just getting past all of it. And you're supposed to return the cheapest like cost that you can pay to reach the top of the staircase. And so simplifying it a bit, essentially what you need to do is you need to start from the beginning of the array, like a pointer at index 0, right? You need to move all the way past the last index, so like be over here, and every time you move, you have to pay whatever cost the index that you're standing on, that's the cost you have to pay, and then so you add it up. So, and you can either start from index 0 or index 1. So if you start from index 0, you can move forward 1 square or 2 squares. So you could start here, move forward 1, and pay 10, and you'd end up here. But the cheapest is to start at the first index, pay 15, and move 2 steps forward, and that's 1, 2, you're at the top of the staircase because you're past the last step. And another example here is you just want to skip these 100s. So this is actually a fairly standard DP problem where you can use what you already know to help you solve the problem. So getting into the solution, the general approach is to maintain an array where each index in the array represents the cheapest cost so far that we can reach the ith step in the staircase at. So for example, in our array, index 0 will represent the cheapest cost it'll take to reach index 0. And you can just start there, so it's free. Same with index 1. And then you can go to index 2. You can just check to get to index 2, you had to either come from index 0 or index 1, because you could start from here, pay this cost, and move up 2, or start here, pay this cost, move up 1. So to find the cheapest spot at cost to reach index 2, you can just compare the number in here, added up the cost of moving from this index. So like this would be our array 0 plus the cost of moving from the 0th index. That's if you came from this way, and the other way you can come from is like this, and that would just be the same thing but with 1 instead of 0. And you could just compare these to costs, and whichever one is smaller, you want to take the minimum of these. You know that since those are only 2 ways to reach index 2, you take the minimum, that's the cost. So you want to put this minimum inside here. And then for index 3, you can just repeat the logic. So you know to get to index 3, you could have come from index 2 by moving 1, or you could have come from index 1 by moving 2. So what you can do is, well, you know the cheapest cost to reach index 2. So you can do, you can grab the cost to reach index 2, add the cost to move from index 2, and that represents one way to reach index 3. And the other way would just be using the values of 1 inside of these, which represents starting from 1 and moving 2 steps. And you can repeat the same thing with 4 and etc. until you reach the end of the array. And the final one, you would just check like ... whatever. You would just say, since you've built up all of these, you know how the minimum cost it takes to reach let's just say this is the nth spot, which is the end. You know how much it costs to reach the n minus 1th spot, that's the cheapest cost. It'll already be calculated here since we're essentially building up this array one step at a time. And then what you can do is just do that same comparison that we've been doing, except fill in the last box, and we can just return whatever we calculate here. And so this is just a fairly standard application of dynamic programming where we use what we calculated before to help us calculate the next thing. And so let's just get right into how to implement this. So it's actually fairly straightforward. It's very similar to what we just talked about. So first we'll initialize a array with the length of cost plus 1 because we want to reach, so if our cost array has like let's just say 4 numbers, so like 1 1 1 1, we know we want to start from index 0 or 1 and move all the way past the third index into like this, right? So we'll, for our array which stores everything, we'll just need an extra box here to store, like, and this is going to store what's the cheapest cost to move past all these steps. And so then we will just fill that with infinity because that just to initialize the cost, right? And then we'll put the index 1 and 0 cost to 0 because it says you may start from index 0 or 1. So we know it's free to reach those. And we can just start at the next index, so index 2, which is exactly what we said here. And we know that is the minimum between, if this is the case if you started at the step 2, 2 steps back. So this is if you went from index 0 to index 2. This is if you went from index 1 to index 2. And so we compute these two costs as the only two ways to reach index 2, take the minimum of that and fill that in for index 2. So now at dp I equals 2, we know the cheapest cost to reach I equals 2, and this will continue on. And it's important that we have I is less than or equal to cost.length, because then we'll be able to, that'll loop all the way until this last box here. And so after we fill it all out, this entire array will be filled out. We can just return the last box, which is going to be the length of cost. And yeah, so that's about it. Pretty straightforward problem. If we run it here, accepted, the runtime of this would just be O of n, and this is easily fast enough because cost.length is only 1000. So yeah. So yeah, that's about it for this video. Thank you very much for watching, and I'll see you guys later. Peace.